Okay, so the topic for today, types of RFC communication. So we have the four types of RFC communication methods here. One is the synchronous. One is the synchronous here. One is the synchronous synchronous connection. Second one is the async. So asynchronous RFC. The third one is called the transactional RFC. There is a transactional RFC. Then fourth one is called the queued RFC. So queued RFC here. There are the four types of RFC communications are there here. Four types of RFC communication methods here. RFC communication methods here. So synchronous RFC, which means in this type of RFC communication, so RFC means why we will use it. So this is the one system. This is the one system to transfer the data from here to here, one system to another system. We will use the RFC connection. So in this RFC connection, there is a communication methods, right? Synchronous RFC, which means source system will send the data to target, right? This is the source, this is the target. Okay, so this is the source system, source, right? This is the target system here, this is the target system here. So source will send the data to target, so via synchronous means source will send the data to target, then target will receive the data, will send back to the source, will send acknowledgement back to the source saying that I have received your transaction, like that. So in this communication, source will send it, target will send the acknowledgement, then source will send the one more transaction, target will send the acknowledgement, source will send the third transaction, target will send the acknowledgement back. So in this way, synchronously both the communications are happening here. In this case, both the systems are involved, must be available at the time of call is made, with the time of the data communication, so source and target must be available in the time of communication. Suppose like client copies. When you are sending the client copies, data transferring is happening from source to target, remote client copy. So your target system also should be available. In case of target system is down, then client copy will be failed, right? So which means both the systems are available. That is the synchronous communication. Here. So asynchronous communication, which means in this type of RFC communication, so we don't require, it's like a request will give the request to the your remote system, means your target system. So the step is it will send it to the target system. The target will not send any acknowledgement whether it is received or not. The target system is not available here, right? If the which means it does not require any acknowledgement from the target. So source will send the data to target, then target will send the acknowledgement back, will send the reply to I received it. That is a synchronous. So asynchronous means source will then send the transaction to target, then target will not send any acknowledgement. Here. In case of target system cannot be reached at the time of the call, the asynchronous calls of the RFC clients are lost. Like, so if it does not send, it will, if not, it does not send. Like, suppose whether source does not bother, mainly is source does not bother whether my target received the transaction or not, it does not bother, since the target is not sending any response to the source here, right? You are sending the text message to your friend, right? Your friend. So if your friend is acknowledged, normally in the previous mobile phones, we have the option, delivered option, right? In the not the smartphones. So normally previously, when you send the normally in the when you type the message to your friend, you will get the one message. Your message has been delivered successfully, something like that. You will get the one acknowledgement from the your friend, right? But Nowadays, we are using the smartphones. There is no acknowledgement. You are keep on sending the message whether you are not sure or whether your friend is received or not. So that is called the asynchronous. If you receive the acknowledgement, that is the synchronous. If you are not receiving the acknowledgement, that is the asynchronous. That is the async mechanism here. That is the async mechanism here, right? So for this two, we don't have any transaction codes. Why? Because these are the internal communication methods here. But the transactional RFC, the transactional RFC. So the transactional RFC, the third one is the transactional RFC. This type of communication is similarly a synchronous RFC, but each and every transaction when you are sending to the target, it will assign the one transaction ID. So this will guarantee if a request is sent to several times because of the network issue, multiple times same request is going, then it will stuck in the source system itself. So it will stuck in the store system itself here. The data will be held in the source system until the target system is available or until target system will clear the transaction, data will not go. Means transaction ID. When you are sending the data to the target, it will create a one transaction ID to your work. Then once the target is available, then data will be sent to the your target system here. So that is called the transactional RFC. Transactional RFC. So in SM58, we can see the SM58 is the transaction codes. Here we can see the list of transactional RFCs and everything. We can see it here, transactional RFC, which means each and every transaction, it will create the one transaction ID. You can see. So whenever, so we have the some transactions got stuck here. SAP star DDIC, they are the some transactions got stuck in the SAP system here. So which is going to target system is this is the target system via RFC destinations. This is going to the target systems here, RFC destinations here, right? So what is the data? Logon data is restored, relative logon data password is incorrect. There are a lot of things. So here, each and everything here, there is a one transaction ID got assigned here. One transaction ID got assigned here. You can see there is a transaction ID got assigned here, right? So by basically this transaction ID for this data, this is the transaction ID. For this data, this is the transaction ID. In this way, we have the guarantee saying that, so it will not send the duplicate data to the target system. So it will not send the duplicate data to the target system here. So we have the transaction ID got failed it here. So this way we can say, so there is no duplicate data to received by the target system here. In case of any network issues or some system issues, system will not send any duplicate data. System will not send any duplicate data here. That is the transactional RFC, which means each and every transaction in the system in whatever the users done the transactions, system will assign the one transaction ID. So this transaction ID is unique for it's separate. Each and every user, each and every output, this is a separate here, not the same. So that is the transactional RFC. In SM58, we can see the transactional RFC, right? So we can say if any entries got stuck in the here, we need to inform to the functional team here. Why? Because the data got stuck in the SAP system. The data got stuck in the SAP system. Then we have to inform to the SAP team to take like develop functional team. They will take care of the next step here. They will take care of the next step here. That is the transactional RFC. Means so each and every transaction, there is a ID will be assigned. That is called the transaction ID. In this way, we don't get any duplicates of the data and everything here, right? That is the transactional RFC here. So the next one is called the queued RFC. Queued RFC here. Queued RFC. So queued RFC here. So queued RFC means, so queued RFC means here, this is the extension of the transactional RFC here. In this method, all the requests are queued up. All the requests are queued up here, inbound queues and outbound queues. And are processed in a sequence only. All the processed in a sequence. In the sequence wise, and the once the procedure is completed, then it will process the next transaction. In the queue wise, it will process the transactions correctly. So this method guarantee all the requests are processed in a sequence which are they have received it. A sequence wise, we have to send the data, right? Some SEM queues, CAF, SIF queues. So the order wise, we have to, so sequence wise, we have to process the data here, queues wise. Sometimes some systems we may have to send the data to, sometimes we may have to send the data to the, sometimes we may have to send the data to the target system just in a queue wise, order wise, we have to send the data. So that time we need to use the queues here. Queues means there is a inbound queue and outbound queues here. Inbound queues and outbound queues here. Inbound queues means which are coming to inside of the system. Suppose like example, so this is the one system. This is the one more system here, right? So this is the source system. This is the target system here. So you are sending the data to this system, which means this system has the inbound queue in, which is coming inside of the system, which is going outside of the system here, outbound queue, right? So let me write it here. Inbound. This is the going outside of the system. Then this is the outbound system here, outbound. This is the inbound and this is the outbound here. Then when again this system is this system also will receive the data, right? Then that time this is called the inbound and this is called the outbound here, inbound and outbound. Each and every system there is a in and out here, right? So data will come to inbound here, that is called the inbound. Then after that some addition, some adjustments will happen, then data will go to the outbound, that is called the outbound, that is called the outbound queues here. So every data there is a inbound, then there is a outbound data is there here, inbound and outbound, right? So this procedure we will call it as the inbound, right? This procedure will call as the outbound here, right? Inbound and outbound here. So there are the transaction codes. So in this way all the queues will receive the transaction in a sequence wise. Sequence 1, sequence 2, sequence wise. So sometimes we may have to split the table records into the chunks wise, smaller. So the first it will go to, second will go to insert, third will go to insert on below of the third, fourth, fifth, like that sequence wise. The data insertion will happen in the systems here, right? Data insertion will happen in the system. Sir, where we have to see in SAP level here. In SMQR, that is the inbound scheduler, inbound queue in, which is coming inside of the system here, SMQR, which means inside of this one, like configuration of the queues, SMQR, inbound queues creation and configuration will do. Then SMQS, then outbound queues and everything. Outbound queues, we will do it configuration in the SMQS here, right? So outbound, which is going out. Out means via RFC destination. Via destination, it will go out, right? So that's why we have the via destinations, we will configure it here. Just click on the register, then which system, what is the destination and which system you want to transfer. So what is the destination, which system you want to transfer, select the destination, click on the OK button. Then so you have the RFC connection is here. Then queue out scheduler, out, which is going outside of the system, which is going outside of the system means so via another RFC destination, right? Another RFC connection. Then it will go to the other system. How it will go to the other system? Via RFC destination, right? So means SMQR, SMQS. So via RFC destination, we need to select it here. Via RFC destination, we need to select it here. Okay. Via RFC destination, we have to select these connections and everything here, right? So that is the configuration we have to do it here, right? So where can a configuration side, we know like SMQR means which is coming inside of the system. When the data is coming inside of the system, so there is a queue wise, it will go, it should go, right? In which queue? The queues creations and everything we have to do it via here, like some of the SIF queues. We have to do the registration like that, SIF queues here. So like that, we have to do the queues creations we have to perform. Normally, in the organization, the either developer functional team will perform, or they will ask us to, they will give us the queue name, they will ask us to create it here. Then we will go to the registration, then we will do the configuration here. That's what will happen in the systems here. Okay, so that's the queue initiated. But monitoring perspective in SMQ1, outbound queues, here we can see for the which are going to outside, how many queues got stuck here. SMQ1, SMQ1, SMQ2, how many queues got stuck in the system, it will tell you the details here. SMQ1, all right. So monitoring the outbound queues. SMQ2, so monitoring the inbound queues. SMQ2, SMQ2. So inbound queues, which is coming inside of the system. So nothing is there. If anything failed entries, we have to inform to the dev. SMQ1, SMQ2, SMQR, QS are the configurations. Queues and everything configuration, we will do it. But production, we may see the some data. If we go to the here, if we go to the production system with the basis user, here you can see SMQR. R means, so here you can see that here you can see the, so data is the number of queues are there here, right? SMQS, you can see the data is there here. Number of data queues are there here, sales related data, everything here. So if you go to the SMQ1, so outbound data, which is going outside of the system here. So if you just do it here, see many entries got stuck, which is going to the BW system, GRC system, some other click QRFC systems. There the many entries got stuck in the systems here, which means this data got stuck in the SAP system here, outside of the SAP system. Means it's not going to the outside of the system here, right? When some Q2, so inbound queues, which is coming inside of the system, here. If you see it here, so if you see it here, nothing is there here. Inside of the system, all the data got processed, which is going outside of the system, SMQ1, outside of the system. Then other we have the, so 651 entries got stuck. 651 entries got stuck here, which is going to the destination. One is the B3, BW system, GRC system. So we have the number of systems are there here. You have the systems are there here, which means these all entries got stuck here. So from our side, we can select it and we can execute it here. We can execute the, so entries here. In case functional team was ask us to do the execute, we can execute it here. We can execute it. So we can execute it. There is a execute button, so we can execute it. Otherwise, so we can inform to the functional team, they will take care of this queues and everything. They will take care of that one here, right? They will take care of that queues creations and all those things in the systems. So that is the queues creations and everything here, the SAP systems here, right? So this is a small concept like queues creations, inbound queues, outbound queues, monitoring the queues, and all those things here. SMQR, SMQS, SMQ1, SMQ2 here. Only outbound queues, we have the, so outbound queues, we have the concept is there here, right? Inbound queues, outbound queues. So in the 4 types of, we have the synchronous, asynchronous, transactional RFC, SM58, and queued RFC. In the queued RFC, via queues means how we will onboard the flight or bus via queue, line wise, order wise we will go, right? Same as like here. So via queues means in a sequence manner, we will go to the, so data will go to the other systems. A sequence manner, data will go to the other systems, from one system to another system. In a sequence manner, it will go. So queue, main thing is you need to remember inbound queues means which is coming inside of the system. Outbound queues means which is going outside of the systems. Okay, in and out. That is what you need to remember. Okay, that is the, so it's the RFC communication types here. RFC communication